The following clip comes from our Dino Hunter series. Check out the full program using the provided links.
Mark's next step was to prepare parts of the horn for examination under the electron microscope.
I started making thin sections, and usually the first sections that you get, you don't find anything right away. That's typically how it goes. Then all of a sudden, these little osteocytes started to show up in the tissue.
Osteocytes are cells that help rebuild bone material. They usually only live as long as the bone is alive, so the fact that they are still found in dinosaur bone is remarkable.
I had to go back to the reference manuals and compare them with what I was seeing, and lo and behold, there were exact copies of what was in the manuals. I knew I had osteocytes right away, so that was very exciting. And so for weeks and weeks, I continued to do thin sectioning, made hundreds and hundreds of slides. I've probably made 5,000 sections of the soft material from the Triceratops horn. I submitted a picture for publication as a cover to American Laboratory. It was accepted. In addition to the osteocytes that we found in the scanning electron microscope, which were thrilling to see, there were other features in the dinosaur bones that really stood out to us. The high degree of permineralization in some of the vessels, where you could tell the walls were hard, solid crystalline material that were laying in the vessels over the time that they became fossilized. Some of them are round. They look like actual red blood cells. And so we called them blood cell-like objects in our paper, just the way Mary Schweitzer did. But others of them are crystallized in beautiful crystalline form. In addition to this high degree of permineralization that we also saw, for example, in the fractured ribs of the Triceratops, beautiful thin vessels sticking out of the center of what we call Haversian systems. In bone, the osteocytes are the little cells that lay down the bone around the vessels. So you have a vessel, a blood vessel, delivering blood to the bone, and the osteocytes build little rings of bone around the vessel. And so you see these circular concentric rings with little pits in them. The little pits are where the osteocytes live, and then they extend their little pseudopodia through all the bone to touch each other. And so it was really neat to see some of the vessels in the fractured bone extending out, just thin wisps of soft vessel in this hard bone. That was very rewarding.
Thanks for watching our content. Awesome Science Media has produced over 50 hours of great kids programs and documentaries on science from a biblical worldview. Want to see it all? The two best ways are streaming it on our Patreon channel or purchasing it for download on our online store. Check out the links below. Get access to our full kids programs and documentaries by supporting our Awesome Science Media page on Patreon. Get behind the scenes segments, photos, and bonus interviews. There are also complete curriculum guides, teacher guides, student guides, and discussion tools. There are fun extras like coloring pages, word finds, and activity sheets. Plus supporter-only updates, live hangouts, podcasts, and blogs. Sign up for free to get our updates or cancel at any time with any of our monthly paid plans. Don't want to subscribe? Have it your way. You can just purchase our content and teaching materials. Every option supports us to reach even more families worldwide with faith-building science content. Sign up today at patreon.com/Awesome Science Media. Or buy our content and download it from our online store at awesomescienceshop.com. You can purchase individual programs or save money and buy the entire series. Each title comes with a download link for your local device, plus a streaming link if you want to use that instead. Our online store also includes teacher resources, merchandise, and additional resources such as books and guides. Check us out today at awesomescienceshop.com. See the link below to access our full episodes.